This is lesson 1.3, Algebra with line segments. We're going to go ahead and start with the warm-up. With the warm-up, just looking at these 2 points, I want you to plot these 2 points, then find the midpoint, and then the length of that line segment, AB. So go ahead and pause the video, go ahead and work through that. This should be a review from the previous lessons, see how you did, and then we'll continue with the lesson. Alright, so here are the 2 points, so -2, 4, and 3, -2. Went ahead and connected them, so this is our segment, our line segment AB. To find the midpoint, we have a couple of options. I'm going to count the length of this side. 1, 2, 3, 4, 5, 6, so that's 6. This is 1, 2, 3, 4, 5, that's 5. So one way to find it is to just split the vertical and horizontal side, find the middle point, and then go over to the actual line. So here, if I count 3 down or 3 up, that would put me right here. If I cross over, that will put me at this point. That would be the midpoint. I could do the same thing here horizontally. This is 5 long, so if I went 2.5 over, that would place me here. And so that line segment there, or that point, that midpoint, is 1/2, 1. So that would be the midpoint of segment AB. We could also do that using the formula x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. In other words, we would just find the average of the x and y values. So this would be -2 plus 3 divided by 2, and this would be 4 plus -2 divided by 2. If I add those together, I get a 1 over 2, which is 1/2. If I do this, I get a 2 over 2, which is 1. So 1/2, 1, which is the same answer that I got here graphically. Now, what about the length of the segment? Well, for that, we can just use the Pythagorean theorem. A squared plus b squared equals c squared. So we can use a and b as the length of the leg, so we'll just do 5 squared plus 6 squared equals c squared. So that is 25 plus 36, which is 3, 4, 5, 6, 61 if we add those together. Now the problem with 61 is it's not a perfect square. So remember, when we're looking at this, and I'm just going to go ahead and maybe draw this in as a highlighted. Here we have 1, 2, 3, 4, 5. When the Greeks looked at squared, they actually saw these as squares. So here's a representation of 5 squared. So this area, and then we'll do 6 squared here, so 2, 4, 6. Draw that over. So here we have a 6 squared, or a 6 by 6 squared, and a 5 by 5 squared. This has a total of 36 squares. This has a total of 25 squares. This square, if we were to make sure it was the same length, so it truly is a square, all 4 sides are equal, this square would have the same area as these two added up. That's what the Pythagorean theorem says. The only problem is this isn't an even number, like it isn't an integer, like this is 5, this is 6. Between, if we look at 7 squared and 8 squared, that's 49 and 64. 61 falls in between this. So I can't make a perfect square using this as the total number of blocks and get a nice even number like 7 or 8. It's going to be some sort of decimal. But that's where we can bring our calculator in. So if I use a calculator, I can go ahead and put the square root, so second, and then we'll hit this x squared above it, that's the square root symbol, and we'll put a 61 in there. And so this will give us a number somewhere between 7 and 8. It'll be closer to 8 than it is 7. So we need to change the mode to classic. Quit. And then let's do that again, 61. So it's about 7.8. So we'll put C is approximately 7.8. So if I do 7.8 squared, I get pretty close to 61, right? So I could put more decimals in my answers if I wanted, but we'll say that that's close enough for what we want. So that's how we use the Pythagorean theorem to find the distance. All right, let's go ahead and move on to the other problems here. Now, the main part of this lesson is to use algebra with line segments, and in each of these problems I'm going to have a line segment on the top that's broken up into two smaller segments, and then a line segment on the bottom. In each case, this total length and this total length are supposed to be equal to each other. So this segment plus this segment that's 11 long should equal to 16. For this first one, we would simply say that, whatever that line segment plus this line segment, which is 11 long, should equal 16. I could take the 11, flip it over, and make it 16 minus 11, right? We flip it, change the sign, and then we have a war going on there. The positives will win by 5. So what we're saying is this length for AB, that line segment should be 5. For this one here, we've got a similar thing going on. So we have 15 plus an unknown line segment, but we know that these two together total 90. So I can take the 15, flip it to the other side. We'd have 90 minus 15. And then if we do that, that is going to be 75. So RS, that line segment, is going to be equal to 75. Now we're going to go ahead and move on and use actual variables instead of a question mark there. And so these will be equations that we have to solve. So for this one here, I know that these two line segments should add up to this one. So 2x minus 1 plus this line segment that is too long, right, has a length of 2, should equal this x plus 7. And now we can go ahead and start doing the math. What I'm going to do first is if I want all my x terms over here and all my non-x terms over here. So the 2x is fine. I'm going to take this x and flip it over. It becomes a negative x. Then we have the 7, which I haven't moved, but now this negative 1 is going to flip over to a positive 1, and this positive 2 will flip over to a negative 2. So remember, when we flip, we change signs. But now I have just x terms here. These are like the rectangle tiles, and then we just have square tiles here. We're going to go ahead and then combine like terms. In this case, this is a war. There would be 1x left over. Here's 7 and 1. That is an alliance. That would make an army of 8. And then 8 minus 2, that is going to be a war with 6 positives left over. And that would be our answer. Now, can we confirm that that answer makes sense? Well, yeah, we can take the 6 and we can plug it back in and double check. So if I did 2 times 6 minus 1, that's for this section here, that is going to be 12 minus 1, which is 11. So this segment is 11. 11 plus 2 is a total of 13, right? So we would say this entire length is 13. So 11 plus 2 equals 13. Now for this segment, we have x plus 6, so that is x plus 7, sorry. So that's going to be 6 plus 7, which is 13. Oh, look. They're both equal to 13. So we have confirmed that 6 is the value that when you plug them in, you do get that answer. Let me see if I can get this zoom in a little clearer. Yeah, it's a little better. All right, let's do the next one. Similar type of problem. The 6, x plus the 6, should equal the total length of this other segment. So we just plug those together, and then same thing. We're going to do flipping. If it has an x term, I'm going to flip it over here. So I have 6x minus 8x. And then I still have the 2 here. I haven't moved it. This 6 is going to flip over into a negative 6. This is a war. The negative wins by 2. This is a war. The negatives win by 4. And now there's a couple of options here you could do. You could, at this point, you're at the division step, you could divide both sides by negative 2. And you can get 2 as your answer. Or you could choose to flip these and make this a positive 4 equals a positive 2x, then divide both sides by 2, and you get an x equals 2. Same answer. Doesn't matter to me which way you want to apply that. Now let's check to see if our answer works. So we got 2, so 6 times 2 is 12, equals 12, sorry. That means this segment is 12, that is 6, so 12 plus 6 equals 18. That is the length of this top line. I should do this. So, or actually it's the length, should be the length of both lines, right? Let's try the 8x plus 2. So 8 times 2 plus 2. That is 16 plus 2, which is 18. So we've confirmed that each segment is worth 18. Alright, we just have 2 more problems now to do. In this case, once again, this segment plus this segment should equal the total length, right? So these should be a length of 13. So all I have to do is add up the parts. X plus 15 plus x plus 8 should equal a total of 13. So now that I have this, I can go ahead and I could do flipping first. So I'll leave the x plus x here. Here's my 13. Flip that, it becomes negative 15. Flip the 8, it becomes negative 8. And now we can start combining. X plus x is 2x. I think I'm going to do an alliance with these negatives here. So I'm going to leave that 13 alone. A negative 15 and a negative 8 make a negative 23. So 2x is equal to a negative 10. Divide both sides by 2, and x equals negative 5. Well, does it work? Well, let's try it out. It's kind of odd because, it's a negative number. Can x be negative? Well, as long as it doesn't make these segments negative, it should be fine. So we're going to go ahead and do negative 5 plus 15, which is 10. So that segment's 10. And then we'll do negative 5 plus 8. That is a 3. And so we have a 10 plus 3 equals 13. That checks with that. So it does work out. Let's do the last one. 2x plus 28 plus x plus 18 equals 10. So here I'm going to go ahead and just combine like terms. The 2x and the x make a 3x. And the 28 and the 18 make a 46. And then we will flip the 46 over to the other side. Sorry about that. It's 46. Then we'll combine those together. That'll be a negative 36. And then we'll divide each side by 3. Negative 12 is the value for x. Well, let's see if that's true. 2 times negative 12 plus 28, that is negative 24 plus 28, which equals 4. And then we'll do negative 12 plus 18, which is a 6. So that is going to be a 4 and a 6, and 4 plus 6 does equal 10. Alright, that is the conclusion of this lesson.